and the microbial water quality standards that are in place for this post-harvest water. Again, water that you're going to be using for washing, potentially for cooling of crops, for transport of crops, and also for cleaning and sanitation purposes. So this water that you're using for any type of post-harvest application needs to have a microbial quality level that is equivalent to the drinking water standards set out by EPA. And that drinking water standard is there is no detectable generic E. coli in 100 milliliters of that water. So generic E. coli, this is an indicator microorganism that we commonly use both in food safety and water quality that gives us kind of a sense of whether microbial pathogens might be present in that water source. So these indicator organisms, this generic E. coli, they're not pathogenic themselves, but they come from the same source as many of the microbial pathogens we're concerned about. They have similar stability in the environment as microbial pathogens. So the presence of these indicator organisms gives you a sense of whether or not the environment would be conducive for these pathogens we're concerned about being in that same environment. So it's also important to understand for post-harvest water whether the water you're using is considered single pass water or whether this is recirculated batch water. So single pass water would be, for example, what's shown here with the strawberries, where you have water that's rinsing over your produce. You're not recollecting that water and using it on a subsequent batch of produce that you're rinsing. So this water is used once. And so when you start using, of course, that water has to be potable water when you start, but there's, less concern about maintaining the quality of this water because we're not intending to reuse it down the line. In contrast, if you are, say, collecting that water after you rinse the strawberries with the intention of rinsing another batch of strawberries, or if you're using any kind of dunk tanks where you're using the same water to rinse multiple batches of leafy greens, for example, in that case, the quality of that water can decline over time. And so if you're using batch water or recirculated water, you need to ensure that the microbial quality of that water is maintained throughout its use. So you have to have zero detectable generic E. coli in that water for the duration of its use. So typically that's going to be achieved by adding sanitizers to that batch water or recirculated water. And so adding sanitizer to that water, the intention is to maintain the microbial quality of the water. It's not intended to disinfect or inactivate any microorganisms that might be on the surface of the produce. So that's a really common misconception that folks have. Oh, I'm adding chlorine to my batch water. That means I'm going to eliminate any pathogens that are on the surface of my leafy green. That's not the case. It's very, very challenging to eliminate a microbial contaminant from the surface of a piece of produce once that contamination event has occurred. What the sanitizer does within that wash water, say I have one piece of spinach that has some bird droppings on it. If I put that spinach in the water, any pathogens that might be present in those bird droppings would then be released into that water. And then every other batch of spinach that goes into that same bucket of contaminated water would be at risk for cross-contamination with that pathogen. So really, really important to manage the quality of your batch water. There's many different types of sanitizers that can be used for this purpose. Many folks turn to chlorine-based sanitizers, but there are other chemistries out there as well as physical means for maintaining the microbial quality of your pre-harvest water. So next,